Hello again, continuing with part 2, common emitter circuit. Previous video we discussed how an NPN transistor works. Just to quickly reiterate, this has to be forward bias, base emitter to allow collector current to flow through the emitter. We have to figure out the voltage drops. Now, there is a quick way to estimate and to assume the voltage drops without calculations. First thing is, this is a voltage divider, a bias resistors, so to say, that will set up the bias going to the base, the voltage going to the base. R1 is 150K, R2 is 10K. Voltage supply, 24 volts. So, there is a formula to figure out the voltage divider voltage across this resistor. And this is this formula. We take VCC, in our example, is 24 volts. We take R2, 10K. And then R1 plus R2. This plus this will give you 160K. And I calculated it comes out to about 1.5 volts. That's by using the formula. Now, Ohm's law, voltage divider. Forget about this part for a second. We can use a voltage divider rule and say, now, this is 10K. This is 150K. This is 15 times more than this. Therefore, this voltage and this voltage would have a ratio of 15. So therefore, this voltage has to be 15 times more than this one. What would give you that? Simply, if this was 1.5 volts, this will be 15 times more. That's how you figure it out. If this will be 2 volts and 15 times more, that wouldn't make sense because it would be 30 volts. So you have to find a combination somehow of the voltage divider without using the formula that this resistor is 15 times more than this. So, once you get 1.5 and 15, will give you, we have 1.5 across here. That means, if we know the whole thing is 24 volts, and we know from here it's 1.5, we subtract. That means this voltage drop is 22.5 volts. You could do it by the formula, or you could do it by voltage divider. Now, I figured out the current, but let's go over here. We know this is 1.5 volts. We established it from a formula or by voltage divider rule. We know we drop 0.6 volts. 0.7 volts, 0.6 volts, doesn't matter, across a forward bias junction, base the emitter. This leaves us with 0.9 volts at the emitter. Great. Now we have to figure out R4. Well, from Ohm's law, we know if we have the voltage and we have the resistance, we can figure out the current. That's Ohm's law right here. As you see, I made orange is orange and orange is orange. Now, green is this green. Let me go away. So, now, this is 0.9 volts. Across over here, we plug in the values. We know 0.9 volts across R4. We calculated it. We know the resistor value, 1K, equal 0.9 over 1 times 10 to the 3rd, equal 0.9 milliamps. We know 0.9 milliamps is going through here. Now, a very important point. If we know 0.9 milliamps is flowing through this resistor, and it's a combination of base and collector, actually, the small current that it takes to excite this is almost, you can almost not even included in this sum of current. It's so small compared to this. So therefore, we can say 0.9 milliamps is also flowing through this. So collector current is almost similar to the emitter current, even though it is the sum of two. Therefore, if we know 0.9 milliamps goes through here, we know 0.9 milliamps goes through here. They're similar. Therefore, 0.9 milliamps times 10K. We want to find out the voltage drop. We know Ohm's law tells us the current times resistor. Therefore, if you do scientific notation, ER3, I times R3, we know 0.9 milliamps times 10K, which is actually not 0.9 times 10 to the minus 3 times 10 to the 3, gives us 9 volts. Therefore, R3 is equal to 9 volts, as you see I represent over here. That's important, because you know why? Now, if we lost 9 volts across this resistor, it's called the collector load resistor, the load resistor, that gives us 15 volts. How? 24 minus 9 volts. We have 15. Another thing, we know we have 0.9 over here, as I indicated. Therefore, from here to here, we subtract 15 volts over here, 0.9 volts over here. We have to calculate and say, okay, that leaves us 14.1 volts DC from here to here. That's how you calculate it. Like I said, you can calculate it like you did over here, and common emitter has current gain more than one. It's beta, it's called phase reversal, and voltage gain. A quick method is, well, like I just said, without doing any formulas, voltage divider. This is 50 times more. You can figure that out as I explained. We know that this will be 0.9 because we lose 0.6. So right away, 0.9 volts should be over here. If this is 0.9, then we know that also we can figure out the current, and then the current goes through here also, and we lose 9 volts. Once we lose 9 volts, that's it. We know we have 15 volts here. That's the quick way to figure it out. I will go over the other parts, the voltage gain and other parts, and common emitter, why it's called common emitter, in the next video. Thank you.